How are you?
Good. How'd you do on your verifying trig quiz?
She actually turned it into a partner quiz, so my partner and I did well. We had like a 96.
Okay. Well, that's good. So what are you on to now?
Solving the trig equations.
Okay. What do you
I'm
got?
sending you a picture now.
Okay. Just one sheet?
Yeah.
Okay. Oh, one sheet, but lots of problems on it.
Yeah.
It's okay. Alright. I think I can make these out. You may have to elaborate a little bit. Let's see, the top says over the interval 0 to 2 pi, right? No calculator? What's that?
Yep.
Still no calculator for you. Okay. Most of these problems you're going to solve just like the way you would solve algebraic equations.
Okay.
What's the first step?
Get x by itself. Get tangent by itself.
Well, we'll start by getting tan x by itself. Now what?
Square both sides.
No? At this point, we need to use the inverse trig functions. I don't think you and I have talked much about inverse trig functions. Let's look at a basic one. Hold on. When I take the sine of an angle, I get a ratio, a number. When I take the inverse sine of a number, I get the angle.
Okay.
So, that's an important distinction. Forget about the difference between radians and degrees for the moment. That's the distinction. So if the sine of 30 degrees equals 1/2, which we know it does, then by definition, the inverse sine of 1/2 equals 30 degrees. This is an if and only if. If that's true, that's true, and if this is true, this is true. Okay, so those are equal expressions, basically. And notice that it allows you to solve for angles. In other words, if I said the sine of x is equal to 1/2, how do you figure out x? Well, one way to look at it is I'm going to take the inverse sine of both sides. So it's the inverse sine of 1/2. And when you take the inverse sine of the sine, you get just the x. Well, the inverse sine of 1/2 is an angle, 30 degrees. So that's how we solve for angles, by using the inverse functions. So in this problem, we have the tan of x is equal to -√3. So x is equal to what?
The inverse of tangent √3.
Yeah, and you can, I don't know what your teacher calls it, it's arctan or inverse tan.
I think it's just inverse tan.
What's that?
I think it's just inverse tan.
That's what they call it? Okay.
Yeah.
Either one is correct, inverse tan or arctan. In case you hear the other expression, it means exactly the same thing. So the question is what angle in 0 to 2 pi, remember x can be anywhere from 0 to 2 pi. So what angles in the unit circle is the tangent equal to negative root 3? So first of all, let's look at our triangle, our 30-60 triangle, because it's the one that's got the root 3 in it. Which of those angles is the tangent equal to root 3?
60.
Okay, so that's our basic angle we're looking for, only we know it's not in the first quadrant. So where is tangent negative?
Second and fourth.
Second and fourth. What is the equivalent second degree angle for 60 degrees?
What do you mean by that?
Well, on the unit circle, the tangent of 60 degrees is equal to root 3, and the tangent of 120 degrees is equal to root 3. Only the tangent of 120 degrees is equal to negative root 3. So basically what I'm asking are these formulas right here. In other words, when you are converting an angle that's in the second, third, or fourth quadrant, the way I figure it out is always by converting it to a first quadrant angle based on these formulas. This is second quadrant, third quadrant, fourth quadrant, first quadrant. In other words, if I said, what is the tangent of 120 degrees, you'd plug it into that formula, right?
Yeah.
Making it the numerical equivalent of the tan of 60 degrees, because when you plug in 120 for theta, you get 60. Well, the tan of 60 is root 3. Therefore, the tan of 120, since it's in the second quadrant, has to be negative root 3. So 120 is one of our answers, but only one. So there's one answer. Where else in the unit circle is the tangent negative? You said fourth. What angle in the fourth quadrant is the equivalent of 60 degrees in the first quadrant?
300.
There's your answer. There's your two answers. 300 and 120. Okay?
All right.
Read number 2 for me. I can't quite make it out.
2 cosine x plus root 3 equals 0.
Okay. Solve it algebraically for cosine x.
It'll be 2 cosine x equals negative root 3.
Right?
And then that's equal, x is equal to the cosine inverse negative root 3 over 2.
What first quadrant angle is cosine equal to root 3 over 2? In other words, I'm going to do this in 2 steps. I'm going to ignore the sign for the moment, this sign here. Okay? And I'm going to figure out what first quadrant angle results in this answer, root 3 over 2.
Let me find my unit circle real quick so I can have it out.
You know what's better than the unit circle are these triangles. You don't even need to have it out. I'll draw them for you. Which angle is the cosine equal to root 3 over 2?
30.
Okay, so 30 degrees is our first quadrant angle, but we got a negative sign on it. So we need to figure out where cosine is negative. Which two quadrants?
It's negative in the second and third.
Okay, second and third. So based on that unit circle again, 180 minus theta, theta minus 180, which two angles in the second and third are going to be the equivalent of 30?
It's going to be 150 and what's the equation for the third one? It's
Theta minus 180?
okay, so it'd be
So if you solve that, theta minus 180 equals our answer, equals 30. What's theta?
210.
Okay, those are your two answers. 150 and 210. Second and third quadrant, equivalent of 30 degrees, both negative. And when your answers are in the unit circle, you're always going to have, well, not always, but in simple equations like this, you're going to always have two answers. Because there's always two quadrants where the inverse cosine, or rather where the cosine of x is equal to negative root 3 over 2.
Yeah.
Solve this.
Sine x equals 1/2.
Okay, so x equals inverse sine of 1/2. What's the first quadrant angle where sine is equal to 1/2?
Uh, 45.
No.
Oh, not 60.
No.
Nope, 90, 99. There you go.
Hold on. If you can't create this from memory, then you need to memorize it. That's everything. Well, between that and this, it's going to answer most every single question we're going to deal with today. These two triangles are going to, these two triangles are going to allow you to figure out any first quadrant angle, trig function, for 30, 45, or 60. That's what all of these are. They're multiples of 35, 45, or 60. So these two triangles are a lot easier to memorize than your unit circle is. You only have to remember three things here. The opposite side, you don't even have to remember that because I call them my unit triangles because the opposite side, the smallest angle is always opposite 1. So you really have to remember square root of 3, you got to remember 2, and you got to remember square root of 2. That's it. Those three things. That will allow you to calculate any of these things. So x in the first quadrant is 30 degrees. Where is sine positive? Which two quadrants?
First and second.
What's the equivalent second degree angle?
150.
Right. In other words, the other thing that you need to memorize, not just those two triangles, but these three equations right here. That one, that's pretty easy. They're the opposite of one another. And this one is just twice what the second quadrant one is. So your answers here are that and that. Can you interpret that for me? That looks like 4 sine squared. Oh, no. Number 4 is secant x.
Equals 2.
Okay.
So x equals secant inverse 2.
You can do it that way. Nothing wrong with doing it that way. Myself, I tend to think in terms of sine, cosine, and tangent. So whenever I'm dealing with one of the other 3 functions, I kind of have to do a bit of translation in my head. So inverse secant of 2 is the same as what? Inverse cosine of 1/2.
Yeah.
And it's like that. It's not 1 over the inverse cosine of 2. It's inverse cosine of 1/2. Well, where's cosine equal to 1/2? What first quadrant angle?
It is cosine 60.
Okay. So that's one of our angles because we're positive here. And first quadrant is always an answer for a positive number. Where else is cosine equal to 1/2? Which quadrant?
It's the first and fourth, so it'll be 300's the other one.
Good. There's your 2 answers. You'll notice that these all go like this. Now, is this the way she's taught you to solve these or not? Am I doing something different than she's doing? Okay. I didn't think so. Oops. Well, I already divided by 4. Okay. Now what?
X equals...
Hold on. Before you can take the inverse cosine, you got to get rid of that cosine squared. What would you do if I said x squared equals 1/4 as an algebra problem?
Square root both sides.
Okay, this is no different. So when I take the square root of the left, I get that. What do I get on the right? It's the square root of 1/4. Nice round fraction.
Is it?
What fraction, when multiplied by itself, equals 1/4?
1/6. No, 1/2.
1/2. When you square numbers smaller than 1, they get smaller. They don't get bigger. When you square numbers bigger than 1, they get bigger. But when you square a half, it gets smaller. It goes down to 1/4. So doing these in reverse is a bit tricky because one's not used to using a bigger number, and 1/2 isn't quite the correct answer. What is? It's close.
X equals cosine inverse 1/2.
Plus or minus 1/2.
Oh, that's right, because we're taking the square root. Yeah.
Plus or minus is huge here. So x equals plus or minus the inverse cosine of 1/2, which means inverse cosine of 1/2 and also the inverse cosine of... Let's go through the unit circle here and see if we can find where this is true. How about the first quadrant? Clearly that qualifies because there's a plus 1/2. So where's cosine equal to 1/2?
First and fourth.
Well, it's actually going to be all 4 quadrants because it's plus or minus 1/2.
Oh. So is there going to be 4 answers on this one?
Yeah, there is, and I wrote that wrong. The plus or minus actually goes there, and it matters. So the first quadrant is which angle?
Cosine of 1/2 will be 60.
Second?
120.
Third?
240.
And fourth.
300.
And there's your 4 answers. It's plus there, it's plus there, but it's minus there, and it's minus there. Since we had plus or minus, we've got 4 answers.
So is it anytime there's a square in the problem, you'll have 4 answers? Like sine squared, cosine squared?
Yeah, I don't know that you can always say that, but I'm not sure. Yeah, even tangent squared is like that. Yeah, in these kind of problems, yes. As they get more complicated, I'm not positive I can make that statement. Which one did we just do? 5? Yeah, so let's look at 6.
4 sine squared x equals 3.
Okay. What?
This will be...
What's one of those common first quadrant answers? Look at that little triangle for the 30/60. Well, take the square root of this number. What's the square root of 3 divided by the square root of 4?
It's root 3 over 2.
And that's one of the common ones. That's the sine of 60 degrees. But it also is plus or minus. So first quadrant is what? 60? Well, it's going to have the same answers as the last question had. Exactly the same numbers. 240 and 300. All of those satisfy the condition. If you plug either of those angles, any of those angles, into this equation, it will be an equation.
Okay.
First step here.
Ooh. I don't know. What would it be?
It would be to bring the term in the right over to the term on the left. Let's talk about something before we do that. If I have this algebra problem, how do I solve it? You cannot divide both sides by x. That would appear to solve it.
That's what I was thinking.
That gives you that. Well, that is a solution, but it misses one. Notice the obvious solution, 0, 0, for x, and yet we didn't come up with it. The reason is that we divided by something that could be 0, and when you do that, you lose that solution. It disappears on you. So the way to solve this is to subtract x from both sides to get this, factor an x out to get this, and now you have both solutions, because x can be 0 or 6x minus 1 can be 0. Normally have a 5 o'clock on Sunday. That's my regular timer. Okay, so in other words, only by subtracting x from both sides do we come up with both solutions. This is exactly the same, this problem. We don't want to divide both sides by cosine of x, because if that happens to be 0, we'll lose it as a solution. So let's bring this cosine to the left, giving us, remember, just solve these like you would algebra problems. Now what? Factor out a cosine x, just like the last problem I factored out x. What do you have left?
2 cosine x,
Oh,
or 2 sine x, sorry. And then 2 sine x minus root 2.
okay. Now it solves easily. In other words, the first solution is cosine x equals 0. Well, where does that happen? With 0 and 2 pi, where is the cosine equal to 0?
0.
No, actually not.
Part.
Cosine of 0 is 1. Remember, this is why it's helpful to memorize your curves, is so you can figure out the quadrangles. This is another curve you want to be able to create from memory. You don't want to have to look this up on a piece of paper when it comes time to solving it. Break it up into quarter points. Where is the cosine equal to 0? This point, this point. What are those 2 points on the x-axis?
Pi over 2 and 3 pi over 2.
Which is 90 degrees and 270.
30. Yeah.
So that solves this part. Well, we have a whole nother solution where that can be equal to 0 also. So if 2 sine x minus root 2 equals 0, sine x equals what?
Root 2 over 2.
Okay, where does that happen in the unit circle?
45.
Good. So 45 degrees, and where else? Where else is sine positive? Which quadrant?
Second. And then it'd be 135.
So the 4 answers to this problem are that, and this. For x. Think algebra when you're trying to solve these. Even when you get to quadratic trig functions. Think algebra. Very similar problem.
Bring the tangent over.
And then what?
Take a tangent x out.
Leaving behind
Secant x.
minus 1. Remember, I brought the tangent over, so I have minus a tan x equals 0. Okay? See how I got there?
Yeah.
So tan x equals 0 or secant x minus 1 equals 0. What's the solution for tan x equals 0?
Tangent x, tangent inverse 0. So.
Okay, and where else?
Third quadrant is positive.
Well, tangent has a period of pi. And it goes from minus pi over 2 to pi over 2. And this one's 3 pi over 2. And tangent looks like this. So it's 0 at 0, but it repeats every pi. So it's also 0 at pi. Okay?
Okay.
Whereas secant x minus 1 equal to 0? Or where is secant x equal to 1?
One.
What's the reciprocal of secant?
1 over cosine, or cosine.
Which means we're in the same place as cosine x is equal to 1, right?
Yeah.
Because since they're the reciprocal of one another, if the secant x is equal to 1, the cosine x is equal to 1. So let's look at our cosine curve again. Where is it equal to 1?
Pi.
No, actually right there. This is 1. So it's at 0. So x equals 0 degrees is one answer. And it doesn't get back to 1 until 2 pi. But 2 pi is outside of our range, I believe. Where's the bracket here? Is it on the 0 or the 2 pi? Yeah, the parentheses are on the 2 pi, the brackets with the 0. So that means we can't include 2 pi as a solution. So therefore, the solution here is 0 and 180 degrees. We had 0 twice. Okay.
Bring the tangent over.
Okay, I'm going to reverse them when I do that, just because most people prefer to have their stuff they're solving for all on the same side, on the left side, rather. Same
Factor out of tangent x.
Leaving,
Tangent x minus 1.
leaving,
Tangent x, or no, minus 1, sorry. Or 1. 0.
Make sure that when you do this, actually, we don't need to factor out a tan. What's 2 tan minus 1 tan?
Tangent.
And we do get the same thing if we factor it out. By the way, we get tangent x times 2 minus 1. When you factor stuff out, always do a last-minute check to make sure that when you redistribute this, you got what you started with. 2 minus 1 is 1, so we get tan x. But we didn't need to do any factoring there. We got 2 tans minus 1 tan leaves 1 tan. So tan x equals minus root 3. Where does that occur? Check your 30, 60, 90 triangle? What first quadrant does that occur in?
60.
Okay, which quadrants are we in?
First and third.
No, it's negative.
Negative. Yeah.
What's the equivalent second?
120.
Fourth?
300.
There's your two answers. In other words, the first is not an answer. It's just the way we do everything to find out the other two, is to always go back to the first quadrant.
Okay.
But for this problem, the first quadrant answer is not a problem because we need it to be negative. All right, let's see. I'm feared that we're not going to get to the hard ones here. So let's skip every other one because this is just like all of yours where this is just the same as that. We'll come back to them if we have time. But I want to go to some of these quadratics because that's what this is a quadratic in disguise. It's actually called a quadratic in cosine x. So treat it just like it was an algebra quadratic. How does it factor? That's how it starts. What are the signs?
Minus and plus.
What are the signs?
Both positive.
Both the same. This plus on the 2 tells you that they have to both be negative or both be positive. The minus on the middle term tells you they have to both be negative.
Okay. All right.
Just like algebra. It's exactly the same. If I had 2x squared minus 5x plus 2, I would factor it exactly the same. Okay, well, there's not a lot of choices on the 2 and 1. Yeah, no, there aren't. Oh, yes, there are. Excuse me. I need the 2 there and the 1 there. And it's different because this has a different coefficient. This coefficient is 2, this coefficient is 1. So 2, 1 and 1, 2 are different answers. But this is the only thing that produces a minus 5 in the middle. Notice the way I always do these. I multiply the inside to check and the outside to check. Add them together, you get minus 5 cosine x. That is our middle term. Okay?
All right.
Almost home. Now what? Let's do this one first. So this times this equals 0 means what?
That one of them equals 0.
Yeah, at least one of them have to be equal to 0. So we're going to solve it by setting both of them equal to 0 and solving. So either that's true or this is true. Now, the zero product theorem doesn't say they both have to be 0. It just says one of them has to be 0. You can't produce a 0 here without one of these things being 0. Can cosine x be equal to 2?
Yeah.
Where?
No.
Where? Is it ever greater than 1 or less than minus 1? Nowhere.
No, it's not.
So it cannot be equal to 2. That is an extraneous solution. However, it can be equal to 1/2. Where does that occur in the first 4 quadrants?
Is it pi over 2?
No? Look at your 30, 60, 90 triangle.
Big 60.
Okay. Notice something. The sine of 30 is equal to 1/2, and the cosine of 60 is equal to 1/2. That's because they're cofunctions. It's always the case that the sine of x is always equal to the cosine of 90 degrees minus x, and vice versa. Cosine of x is equal to the sine of 90 minus x. All cofunctions share this property. So the first one that most people memorize is the sine of 30 degrees equals 1/2. If you don't have that memorized by now, you should. Well, if the sine of 30 equals 1/2, then the cosine of 60 equals 1/2. So actually you should memorize both of those without having to go back and refer to that 30, 60, 90 triangle. In other words, some things are just a whole lot simpler if you memorize them. And that's one of them, these two angles, or this one angle, rather. Okay, so where else is the cosine positive?
Fourth.
What's that angle?
So 300.
There's your two answers. The reason I wanted to do that is because I knew that that was an illegitimate answer. Notice that we're going to do 14 exactly the same. The only difference is that it factors slightly different. It factors 2 secant x minus 2. Oh, actually, it does factor a little different. Let's just factor it. Yeah, we can do this one. I just mainly wanted to skip ahead to some harder ones, and these are a little harder. Factor that.
2 secant, and then secant. And then the signs will be different.
So, in other words, I have to allow now for both of these possibilities. So now figure out what produces this middle term. What combination? There's not very many factors of 2. It's 2 and 1. So where can I put my 2 and where can I put my 1 to produce this middle term?
You can do -2 and then +1.
That doesn't produce that. If I look at that, multiply them both together, they cancel. In other words, that produces -2, that produces +2. So that doesn't do it. A little bit of trial and error here, but not a lot.
So let's flip that then.
Okay, hold on one moment. Let's see. Your first answer was 1 and 2?
Yeah.
That's fine. Oh, no. Your first answer, no, you had it reversed. You had it like this.
Yeah.
Notice that if that doesn't produce the proper number, 3, then there's no point in trying 2 there and 1 there, because I'm going to produce the same number. Okay? So it's not total trial and error. In other words, the next thing to do would be to try putting the 2 on the right side and the 1 on the left. Well, about that. Does that produce the correct middle term?
Yeah.
Yes, it does. Okay, so now let's solve this. And I'm going to erase these. They aren't needed anymore.
So secant -2 equals 0, secant equals 2.
Secant of x equal 2, where does that occur? Is that possible?
No.
Secant and cosecant are the rest of the range. In other words, sine and cosine take up all of the range from -1 to 1. Secant of x has to be greater than 1 or less than -1. So this can happen. That happens where cosine equals 1/2. That happens at 60 degrees. And where else?
Okay. Actually,
What's the fourth quadrant angle for 60?
300.
Fourth quadrant, cosine is positive, so secant is positive. The reciprocal relationships always follow that. Even though it said all students take calculus, in other words, when it's sine or cosecant is positive in the second quadrant. And in the fourth quadrant, cosine or secant is positive.
Okay.
Now let's solve this part. Is that possible?
So that can't happen.
Good. So we only have two answers. Factor this for me.
Sine and sine.
Sine x, yeah, I don't mean to ignore the x, but that's an important part of this. A lot of times I'll leave out the x, especially when I'm doing verifying trig identities, because I don't feel like writing it 100 times. But in this case, I think it's important to know that it's sine x times sine x. Okay. What else?
Both signs will be positive. And then the factors will be either 3 and 2 or 6 and 1, or 6 and 1.
6 and 1 don't work. Just 3 and 2.
Okay.
6 and 1 would produce a 7 right there. So now what?
Sine x equals -2. Then that
Is that possible?
I don't think, no, it's not possible.
No solution.
Okay.
There is no angle in the world where that would be true. Where sine squared plus 5 sine of that angle plus 6 would be equal to 0. Can't happen. And most likely, let's see, this is going to be cosecant minus plus 1, cosecant plus 1, or 2 cosecant, 2 cosecant. This same kind of problem. You're going to get two solutions, both of them are impossible. Seventeen's a little trickier. Can you say if this is a quadratic in x or a quadratic in tan x or a quadratic in secant x?
Um,
You can't say any of them. In other words, it would be like saying, is that a quadratic? And no, it is not. For me to be able to treat this like a quadratic, it all has to be the same trig function.
okay.
So here's where we're going to use our trig substitution, our trig identities, to turn this into a quadratic that I can solve. What's the trig identity for tan squared?
Cos or sine or cosine.
since we've already got part of our quadratic in secant, I'm looking to turn tangent into secant. Besides that, it's tangent squared. Whenever you see squared, think your Pythagorean identities. What's the Pythagorean identity for tan squared that's in terms of secant squared?
1 plus tangent squared equals secant squared, so
that's the identity. Notice that now it is a quadratic in secant x. And we can solve it because of that. How's that factor?
secant, and then signs are going to be different.
Not much choices for factors of 2.
Yeah, I think
It's either 1, 2, or the opposite, 2, 1. Which is it?
I think it's 2, 1.
Always take the biggest factor, which is 2, not 1, the biggest of the 2 factors, and put it on the sign of the middle term. So the 2 goes here. Why? Because it needs to be weighted more heavily because we have to produce a minus 1 in the middle term. Well, there's plus 1. There's minus 2. That gives you a minus 1 in the middle term. Okay. And let's finish solving this.
Secant x equals -1.
Where does that happen?
60? It's either, no, it's 0.
Well, I'm going to draw the cosine curve only because I'm more comfortable drawing it than I am the secant curve. But notice that the secant x equals 1 has to be at the same place cosine x equals 1 because they are reciprocals. 1 is the only number that is its own reciprocal. So there's 1, there's minus 1. Where is it equal to 1?
Cosine is equal to 1 and 0 when it adds 0.
Only at 0. No other place there. And where is secant x equal to 2?
60 degrees.
Good. And
300.
There's your 3 answers. So remember this one because that's almost as hard as they get. 19 looks like it might be kind of hard also.
She told us not to do 19 or 20.
Okay. But notice the common element between 17 and 18. We got 5 minutes. Let's do 18. The common element being that it's almost a quadratic. The only thing that prevents it from being a quadratic is that we got cosine and sine. So we need to change it all to one trig function. Which trig function are we going to change it to? Go ahead.
Sine.
Right, because I can change this into sine really easily. It's not as easy to change that into cosine. If I change this into cosine, we're going to have radicals. I don't want radicals, I want squares. So we're going to change everything into sine. What's the identity for cosine squared?
Sine squared plus cosine squared equals 1. So cosine squared minus 1.
Make sure you do it right. It's not sine squared minus 1. It's 1 minus sine squared. Now, in other words, sine squared plus cosine squared equals 1, then cosine squared is equal to 1 minus sine squared. Okay? Multiply out, distribute, gather like terms.
Minus 2 sine, or would those make that would make a positive, wouldn't it?
Yes, it would. Now, combine everything. We get sine squared of x minus 3 sine of x plus 1 equals 0. Aha! Forgot the 2 right there. It's a good thing. Because what would have been the problem here? What's the problem here? I can't factor it, right?
Yeah.
I would have to use the quadratic formula, and that's okay. There's a lot of these where you would have to use the quadratic formula on. Only instead of x equals minus b, it's sine x would equal minus b plus or minus the square root of b squared minus 4ac all over 2a. She may not give you any like that, where you would have to use the quadratic formula, and this isn't one of them because I had left off the 2. Now I'll put it back on there and it'll factor rather nicely, I'm sure. Into what?
2 sine.
What are my solutions?
Sine x equals 1/2. And sine x equals 1.
Okay, where does the 1/2 occur?
30.
And
The 1 occurs.
now, where's the other 1/2 occur?
Oh.
There's always going to be 2 solutions unless it's a quadrangle. And then occasionally the quadrangles will only produce 1 solution in the
150.
But that's always got to have 2 answers to it. Okay, and this one occurs where?
Sine of x equals 1 occurs.
Draw your sine curve on a piece of paper and see where it hits 1.
Pi over 2.
Yeah, the first quarter point.
Yeah.
90 degrees. So the solution here is 30, 90, and 150. And only 90. In other words, there's really only 1 point in the unit circle where the sine of x is equal to 1. All right. Perfect timing, huh? If you didn't have to do 19 or 20. I wonder why she doesn't want you to do these. Square both sides, probably. Multiply by the conjugate, probably. But we won't worry about them, especially since we're out of time. All right, Jackson.
All right. Thank you very much.
See you next time. Bye-bye.
All right. Thank you.